Hello friends, welcome to the Edupedia world. In this tutorial, we learn something more about abstract classes and we see the concept of interfaces. So let's begin. Abstract method. You can declare an object without defining it. For example, person P. Well, it is actually a reference that you have created without declaring it. Similarly, you can declare a method without defining it. Public abstract void draw int size, and then you place the semicolon. Then int size is a parameter, void is return type, abstract is a keyword, public is again a keyword, and draw is the method name. Notice that the body of the method is missing. A method that has been declared but not defined is an abstract method. Abstract class. Any class containing an abstract method is called an abstract class. You must declare the class with the keyword abstract. For example, abstract class, my class, and then you define data members and member functions. An abstract class is incomplete. That means it has missing method bodies. You cannot initiate or means create a new instance of abstract class. So this is something we have already seen in our previous tutorial. You can extend, that means subclass and abstract class. If a subclass defines all the inherited abstract method, it is complete and can be initiated. So if a abstract class is having all, it is defining like all the inherited abstract method, then it can be instantiated and it is become a concrete class. If a subclass does not define all the inherited method of an abstract class, then it too must be abstract. Fine. You can declare a class to be abstract even if it does not contain any abstract method. This prevents the class from being instantiated. Fine. Why have abstract classes? Suppose you wanted to create a class shape with subclasses, for example, oval, rectangle, triangle, hexagon. You don't want to allow creation of shape. Why so? Because shape does not have its own, what should I say, function, whereas oval does have it. Like oval has a particular shape, rectangle is a shape, whereas shape itself is a kind of feature. You can mention dimensions in shape and you can mention a method draw in shape, but what to draw will definitely depend upon its concrete class. That's why you do not want to allow the creation of shape. Only particular shape make a sense, not generic, obviously. If shape is abstract, you cannot create a new shape. That's also true. You can create new oval, new rectangle, fine, but cannot create new shape. Abstract classes are good for defining the general category containing specific concrete class. So if there is anything like general and it is not having a concrete definition, then you can define it in abstract class but do not provide the definition, and provide the definition only whenever we need to use it. Fine. So this is an example of abstract class where we are having public abstract class animal, and then we are having abstract int eat and abstract void breathe. Fine. So these are two abstract method and we are not having definition of this method. I hope so, that's fine. And this class cannot be instantiated because it's an abstract class. Any non-abstract class of an animal must provide eat and breathe methods. Fine. So this is like now whenever if you create a dog, then dog must provide the definition of eat and breathe. Okay. Then now why do we have abstract method? Suppose, for example, you have a class shape but it isn't abstract. Shape should not have a draw method. Why so? Because draw is not actually defining anything. It is just saying that it needs to draw something, but what we don't know. Each subclass of shape should have a draw method. For example, oval, rectangle, because there we actually know what to draw. Fine. Now suppose you have a variable shape figure, where figure contains some subclass object such as star. Okay, if there is a syntax error to say figure.draw. Why? Because compiler can't tell in advance what kind of value it will be in figure variable because we cannot say like which figure it will be. The class knows it's a superclass but doesn't know its subclass. The object knows its class but it doesn't know its object. So it's only a reference. There is no object. So what is the solution? Solution will be give shape and abstract method draw. Now class shape is abstract so it cannot be instantiated. The figure variable cannot contain generic shape. Why? Because it is impossible to create one. Any object such as a star object that is of a kind shape will have a draw method. Java compiler can depend on figure.draw being legal call and does not give the syntax error. So I hope so you got what I'm saying, that we'll create an abstract shape and then we'll create a draw method without implementation, and then the figure variable which cannot contain generic shape. Why so? Because it's abstract. Thus the object star we need to call the draw method with star and provide the implementation of draw within that star class. So this is like showing you code wise, like we have created a class shape and then we have a class star with extend shape and it is having a draw method, so it will do something in draw method. Then we have another class called crescent. It is also extending shape and it will also override the draw method. Now class shape should be abstract. Now if we try to do shape equals to new star, well, this is absolutely legal. Why so? Because star is a shape. Star is extending a shape. It is perfectly okay, but over here you can see like shape might not have a draw method. Why so? Because we are doing some shape dot draw and that some shape dot draw is only present in crescent and star. It's not in draw. So this is a syntax error. Why so? Because shape might not have a draw method. So in order to make shape have draw method, we can change the type of shape class to abstract and create a draw method without providing its definition. So I hope you remember that a class knows its superclass but no its subclass. So superclass must have that method. So the solution is to change it to abstract and provide a abstract draw method. So you can see over here when we are doing void draw, we haven't actually written the abstract keyword with this method. So we are not writing void abstract draw, which is also fine since we have created abstract class and we are writing a method and not providing the definition. So by default it will be abstract method. Okay. So this is legal. Why? Because star is shape and however shape some shape equals to new shape is no longer legal. Why so? Because now shape is an abstract class, so you cannot do that. So you can only do shape some shape equals to either new star or new crescent. Okay, however shape some shape dot draw is legal because every actual instance must have a draw method. So we are good. Okay. So now interfaces. Well, an interface describe method but does not supply bodies for them. This is the like a syntax or the example of an interface. So what happens in interface? We have seen in abstract class it also provides method, but it does not supply bodies for them. So you can see there is a keyword called interface and the name of the interface is key listener. And then we have three like methods and these methods are a kind of abstract method, implicit abstract method. Why so? Because interface can only and only contain abstract method. It cannot contain simple methods. Okay. So these are abstract methods. So yeah, and again, all the methods are implicitly public and abstract. Even if you are not mentioning public or abstract keyword, it will be implicitly public and abstract. You can add this qualifiers if you like, but why bother? So you can even leave like that. And also you cannot instantiate an interface. So as an abstract class, you cannot instantiate an interface. An interface is like a very abstract class, but none of its methods are defined. You can see that in abstract class we can have abstract method, but we can also have normal methods which are not abstract. But in interface we must have all the abstract methods. Okay. Interface may also contain constants. So constants are like, normal data members. So these data members must be final. So it must be like public and final. So now designing interface. Most of the time you will use Sun supplied Java interface. Why? Because, or we can say Oracle supplied now. Because, there are multiple interfaces that Java has. For example, there is the collection interface. Fine. And if you are, doing, then you have like multiple interface, HTTPs, etc. So all these are interface that Java has already supplied to you to use them. Sometimes you will want to design your own, where you would write an interface if you want a class of various type to have a certain set of capability. There are various types of classes and they do have some set of capabilities. Although, the functionality could be different, but the kind of work it is doing is same, like, draw. Each and every class is doing a draw, but what it is drawing, like, it's entirely different and dependent on concrete class, but they have a set of capabilities, like they can draw or they can paint. So these are set of capabilities. So then you define an interface. And for example, if you want to be able to create animated display of object in a class, you might define an interface as, you can see public interface, an animatable, and then we have install and display two methods which are by default public and abstract. Okay, now you can write a code that will display any animatable class in a panel of your choice. Okay, simply by calling this methods. Okay, so implementing an interface. So the thing is that you extend a class, but you implement an interface. So whenever you're using abstract class, you can use it, extend that abstract class. But whenever you want to, utilize the interface, you always use the keyword implement. A class can only extend subclass one other class, but it can implement as many interface as you like. Okay. So this is a restriction, like a class can only extend one abstract class but can implement as many as possible interface as you want. So this is like a good thing about interfaces. Implementing an interface, when you say a class implements an interface, you are promising to define all the methods that were declared in the interface. Yeah, if you are going to, like implement an interface, then you must actually declare all the methods. For example, we do have like class my key listener, it's implement key listener. Now key listener was having these three abstract method, keep first, key released and key type. Now you need to provide definition of all three of them. Okay. Here dot includes means the code whatever you want to supply. And now you can create my new key listener. Fine, so you can do key listener A is equal to new my key listener. So it's actually creating the object of my new key listener with the reference of key listener interface. Okay, so is it possible to partially implement an interface? Well, let's see. It is possible to define some but not all of the methods defined in an interface. How so? You can see like we are creating an abstract class my key listener and then it is implementing a key listener. So in case if you don't want to implement all the methods of an interface, then you need to make your classes abstract, and abstract class as a usual class can implement an interface. So it has defined just one method and it's not doing anything about the other two methods defined in this key listener interface. So it is absolutely fine. Okay. Since this class does not supply all methods it has promised, it is an abstract class. You must label it as such with the keyword abstract. So in this case, you must write the abstract keyword. Fine. You can even extend the interface. That is also possible. But then a interface can only extend the interface. So it's like a class can extend a class, an interface can extend the interface, but a class need to implement the interface. Fine. So this is like interface fun key listener, extend key listener. So here both fun key listener and key listener are interfaces. So interface can extend the interface. Okay. So what is the purpose of interfaces? What do you think it could be? Well, let's see. The reason one, a class can only extend one other class, but it can implement multiple interface. So this is like a really good use because let's say if you want to, add the functionality of multiple classes, then you cannot do it using an abstract class extend. You can only do it by using implement multiple interface, right? This lets the class fill multiple roles. In writing applets, it's common to have one class implement several different listeners. Why? Because here you want to, actually listen to different events and you can use implement keyword and can implement as many interfaces as you want. So this is like really a good reason why to use interface over abstract classes. Then another reason is you can write methods that work for more than one kind of class. Obviously, I mean simple reason. Like there's a method and that works for 2, 3 classes. So let's make a common interface and define that method over there. And let's declare that method inside, the concrete classes. Okay, now let's see how we can use the interface. Well, you can write methods that work with more than one class. Fine. So we can see there is a interface rule set and then there is a method which is boolean is legal. It is having a move object and a board object. Then we have another method void make move which is having a move object. Now every class that implements rule set must have these methods. So we are having a class checker rules. It is implementing rule set. Okay, so this is one implementation where we are, overriding this method. You can see when we are overriding this method, it's like a public method, so we are defining public, and in case of an interface, it is implicitly public. So over here we haven't defined public, but when we are, overriding it, then we are defining it as a public. So its public boolean is legal, and yeah, one definition. Then we again have a definition for make move. Similarly, there is a class called chess rules, which is also implementing rule set. Then we have another like lines of action rule. It is also implementing rule set. So we can have as many implementation as we want by implementing that interface. Fine. So now in order to create an object, so we can do this rule set is an interface and we are creating a reference of that rule set that will be rules of this game and then equals to new chess rules. Okay, this assignment is easier because rules of this game object is a rule set object. So I hope this is clear. Like, the rule set is like just a reference and actual object that is rules of this game is object of actually chess rules. Although it is object of rule set, but rule set is just an interface. So you cannot create a real object. So the real object will be of chess rules. Fine. But if you try to do this, if rules of this game is legal, you can do that and yeah, and from there you can call this method make move m. So we are, calling is legal method of the chess rules class. Fine, this statement is legal because whatever kind of rule set object rules of this game is, it must have is legal and make move methods. So I hope so it's clear like why do we use interface and how do we use interfaces. Okay, so instance of is something we have already seen. Let's see how this works with an interface. So instance of is a keyword that tells you whether a variable is a member of a class or an interface. Let's see, for example, we have a class dog and it extends animal and it implements pet. Fine. Then we have a reference of animal and we are creating an object of dog. Hope so that's look good. Then the following all are true. What is true? Like Fido is an instance of dog. Well, it is. Fido is an instance of animal. Again, it is true. And Fido is an instance of pet. Again, it's true because animal implements pet. Fine. So instance of is obviously seldomly used, but when you find yourself wanting to use instance of, think about whether the method you are writing should be moved to an individual subclass. So like the saying like you want to move that to some other individual subclass or it's just giving you a hint when you need to create a subclass. Okay, interfaces again. So when you implement an interface, you promise to define all the function it declares, but there can be a lot. Fine. So what you can only care about is couple of this method. Well, you can do that. We have seen. What if you only care about this couple of methods? I just want to implement key pressed. Okay, the solution is a adapter class. Well, over here you can see adapter class is actually a part of adapter pattern, but I'm just going to cover a bit of it over here. So you can see we are having an adapter class. It's implement an interface and provides an empty method bodies. So yeah, it's not writing anything. We don't care what key released is doing or what key typed is doing. So let's keep it blank. And it's also keeping key pressed as blank. That's also fine. You can override only the methods you care about, and this isn't elegant, but it works. I mean, you can do that. It's legal. Java provides number of adapter classes. Okay guys, so I think I hope that you have understood the concept of abstract class and interfaces. So far we haven't done any live example, but I'll be doing the live example of interface and abstract class in the next tutorial. So we'll just recap the vocabulary. So the abstract methods. A method which is declared but not defined. It has only method body. It is called abstract method. Then we have abstract class, a class which is either, contains abstract method or has been declared abstract. It's called abstract class. Fine. Then what is the meaning of instantiate? It means to create an instance of an object. I hope so, that's fine. Then we have interface. Interface is similar to a class but contains only abstract method and possibly constant. Adapter class, well, a class that implements an interface but only has empty method bodies are called adapter classes. So adapter is not a keyword. I mean, it's just attached with a class name just to, signify that it's an adapter and it is having method which is not having anything in the body. So okay guys, thank you very much for this tutorial, and now let's meet in next tutorial and we'll be doing some interesting example of abstract classes and interfaces.